Now we're going to talk about gas evolution reactions. And we can recognize these because we get a gaseous product. Usually you see that as bubbles. So when we dissolved the copper wire in nitric acid, we got a gas given off, right? It bubbled. Now that is not, it doesn't quite meet this definition of two aqueous solutions, but it is the idea that a gas is being evolved. So there's different ways that these reactions can occur. Sometimes the gas is formed directly from the ion exchange. And predicting products for any of these reactions, we're going to use that swapping partners technique, okay? So here, if we swap the partners, we end up with K2SO4 and H2S, dihydrogen sulfide gas, which smells horrible. How do you know it's a gas? Well, I don't expect you to know that it's a gas, except now I've told you that H2S is a gas, and it's one of four things you have to remember. So you can form that just directly. Other times, we're going to get a compound form that decomposes. So here, sodium hydrogen carbonate, that's baking soda, reacting with hydrochloric acid, will form sodium chloride and H2CO3, which is carbonic acid. And then we need to remember carbonic acid is not stable. It's going to decompose quite quickly. The carbonic acid is going to decompose into water and CO2. We should recognize CO2 as a gas. This is a picture of this happening. They're mixing aqueous sodium hydrogen carbonate with aqueous HCl, and you get all this bubbling and fizzing because the carbonic acid is formed and then it decomposes into carbon dioxide and water, and so you see all these bubbles. So this is one, the H2S, I told you, we just need to remember that. And then these are the three that are unstable. And remembering these is not critical to passing the class, okay? Doing stoichiometry, we need to get that down. Unit conversions, that kind of stuff, really important. This stuff, not so much, but the really good students are going to want to have this down because there will be a question or so on exams about it. So H2CO3, we can also end up with H2SO3 or NH4OH. So when you see one of these, you need to say, oh, that's one of those unstable ones. It's going to make a gas. How do I know what gas it makes? Well, I'm going to show you that it's actually fairly easy to predict. So let's look at H2SO3. All three of these, when they decompose, they make water and something else. So this is going to make water and something else. So if I look at this formula and I remove two hydrogens and an oxygen, let's get rid of those guys and change this 3 into a 2. What do I have left? I have SO2. That's the gas. That works with the carbonic acid also, makes water, and take away two hydrogens, take away one oxygen, there's the CO2, that's the gas. And ammonium hydroxide, now that looks very different from the other two, but it does the same thing. It decomposes into a water molecule and whatever is left. So I'm going to get rid of two hydrogens and one oxygen. So I'm going to get rid of the hydrogen at the end, and I'm going to get rid of one of these. So instead of 4, I've got 3, and then I'm going to get rid of the oxygen. What do I have left? NH3, ammonia, which is a gas. okay? Write a molecular equation for the gas evolution reaction that occurs when you mix aqueous hydrobromic acid and aqueous potassium sulfite. So we need to write an equation. They gave us names of compounds. We need to write their formulas. So hydrobromic acid. This is an acid. It starts with hydro, and that tells me this is not an oxyacid. So this isn't going to be HBrO3 or something. This is just hydrogen and bromine. So hydrogen ion and bromide ion, so that's HBr. And potassium sulfite. Potassium is K+. What's the formula for sulfite? SO3. 2 minus. You were telling me the charge. Yeah, right? Yeah, sure. 2 minus. Sulfate is SO4. Not all the 8s are O3. I'm sorry, but that's how it is. So this is K2SO3, aqueous. And I'm going to move this over because I always forget to leave enough room. Let's move that too. So how do we predict the products? Swap partners. H plus with SO3 2 minus, Br minus, and K. So when we're writing the formulas, the cation goes first and the anion goes second, just because that's how they decided to do it. So there we get KBr. Is that soluble? Yes. Remember that the solubility rules, the first line. Lithium, sodium, potassium, ammonium, always soluble. So that's aqueous. And then we've got H plus and SO3 2 minus. So that's going to be H2SO3. This is one of those guys, one of the unstable ones. So there's H2S is just a gas, and then you've got H2SO3, H2CO3, and NH4OH. So this is going to decompose into what? Water and SO2. So HBr plus K2SO3 is going to make KBr plus, what's the state of water at room temperature? Liquid. And SO2 is the gas. Is it balanced? No. If we're just, kind of looking over it, the one that jumps out at me again is the potassium. This is K2 and that's K. So I'm going to put a 2 over here. So 2 Ks and 2 Ks. And then let's look at what else was affected by that 2. Now I have 2 bromines, right? And there's only 1 over here. So I'm going to put 2 bromines over here, 2 HBRs. And let's look at sulfur. There's sulfur and 1 sulfur. And oxygens, 3 oxygens, 2 plus 1, 3 oxygens. So when I taught you how to balance equations, we had some that were kind of ugly, right? They were kind of hard. Most of the time, balancing equations ends up being much simpler than that. just not too tricky. Any questions?